Hello, my name is Om, and today I'm here to help you with solving trigonometric inequalities. Okay, so first I have a trig equation written here, and if you aren't comfortable with solving these yet, I suggest you go on online resources to figure out how to solve those before coming back over to this video. Okay, so here's the inequality that I'll be tackling today, and at first glance you might think, okay, why do I need to learn this? Is this even necessary? And the truth is, yes, this is necessary, especially in word problems. In the future, you'll be faced with word problems that actually model real-life situations, and solving them actually requires the knowledge of trigonometric inequalities. Okay, with that out of the way, how do we actually go about solving this inequality? Well, step one, let's make a substitution. So cosine of theta is greater than or equal to negative 1 over root 2. Notice, the negative 1 over root 2 is the same thing as negative root 2 over 2. So if we draw a very basic unit circle here, here's negative root 2 over 2, instantly this should remind you of the 45-degree angle, which is a special angle. Or since we're dealing with radians, pi over 4. So in quadrants 2 and 3, negative root 2 over 2 corresponds to a related angle of 45 degrees. So this angle and this angle are both 45 degrees. So what does this question mean? Finding angles of theta that are such that cosine of theta is greater than or equal to negative 1 over root 2. So we should be focusing on finding values of theta or angles such that their cosine values are within this interval here from negative root 2 over 2 to 1. This is 1. And what angles fit this constraint? Well, these two bounds definitely meet the constraint, and every angle in between fit the constraint as well. So every angle in here. Okay, so what are these two bounds? Well, the top bound is pi over 2 plus pi over 4, which is 3 pi over 4. And the bottom bound is the negative of that, because you're going in the opposite direction. So negative 3 pi over 4. Hence, step 2, we have just converted this inequality into a compound inequality, so that theta is greater than or equal to negative 3 pi over 4 and less than or equal to 3 pi over 4. But we must also remember the plus 2 pi n. Plus 2 pi n. And this just comes out of the fact that cosine is a periodic function, and because of the periodic identity, which states that cosine of theta equals cosine of theta plus 2 pi. Okay, moving on. We can now resubstitute the value for theta back into the inequality, compound inequality. 2x over 3 minus 7 pi over 9. Let's add 7 pi over 9 to all three sides of this inequality. So, on the left side, you have 7 pi over 9 minus 3 pi over 4, which gives us pi over 36 plus 2 pi n, which is less than or equal to 2x over 3, which is less than or equal to 3 pi over 4 plus 7 pi over 9, which leaves us with 55 pi over 36 plus 2 pi n. Now let's combine these terms. We get pi plus 72 pi n over 36 is less than or equal to 2x over 3, which is less than or equal to 55 pi plus 72 pi n, all of that over 36. And just keep in mind that all I did here was find the common denominator. Okay, moving on. How do we isolate this x? Well, we can multiply all three sides by 3 and divide by 2. So, multiplying by 3, dividing by 2, this cancels. Multiplying by 3, dividing by 2, same thing. And 2 times 12 is just 24 in the denominator. 2 times 12 is 24. Hence, we have just simplified our inequality to, if we factor out the pi, we can simplify it even further into pi times 1 plus 72n, all of that over 24, less than or equal to x, which is less than or equal to pi times 55 plus 72 times n, all of that over 24. So now, in this step 3, we will have to plug in values of n, such that when we get our answer set, we have to make sure that it's within the required interval for x. So let's just start with the simplest case, n equals 0. So if n equals 0, this term is 0, so we're just left with pi over 24, less than or equal to x, less than or equal to, this term is once again 0, so 55 pi over 24. Notice that 55 pi over 24 is less than 2 pi. Sorry, it's greater than 2 pi. 55 pi over 4 is greater than 2 pi, because 2 pi is equal to 48 pi over 24, which is obviously much less than 55 pi over 24. Since this is greater than our bound on the restriction, our answer gets restricted to pi over 24 is less than or equal to x, which is less than or equal to 2 pi. Once again, this is larger than 2 pi, hence we have to deal with the restriction and change it to 2 pi. Okay, so now this is our answer so far, and you might be wondering, okay, what about the interval from 0 to pi over 24? Don't we have to test that? Because it's still within the valid interval. Well, since this interval is less than this interval, we would have to test a smaller value of n. So let's just try n equals 1. Sorry, negative 1, which is smaller than 0. So if we try n equals negative 1, we get 1 minus 72, which is a negative number, negative, less than or equal to x, and we get here 55 minus 72, which is also a negative number. Hence, this interval does not work because the required interval is positive, but the answer interval that we're getting is negative. So this interval does not work, and n equals minus 1 does not work. So, for our final answer to this inequality, x is greater than or equal to pi over 24 and less than or equal to 2 pi, and we are done.